Okay, so here's our review for test number 3. So we're going to start with radicals. Assume that all variables represent positive real numbers, okay? So that avoids having to do any of that absolute value stuff we saw in some of the notes we had to do. I mean, it's something that you'll see in every book that they require you to do those. But a lot of times instructors just eventually just tell students, just assume you're dealing with positive numbers with the variables, so we don't have to worry about that. Okay, so starting on this first one right here, so you just want to look at each one of these parts and square root each one of these individually. So the square root of 169 is 13. Square root of x squared, so it nullifies the square, so it just leaves you with an x. And so right here, see y to the fourth power, that's the same thing as y to the second raised to the second. And so what's going on is when you square root that, it nullifies this power right here. And so we're going to be left with a y squared right there. And so that's our answer for number 1. Okay, that's the easy one. The next one's going to be a little bit more challenging, and I'm going to show a little bit more of my work as we go through it. So let's see, right here we got square root of 20, so I'm going to have to break that apart. So I'm going to break that up into the square root of 4 times the square root of 5. Then x to the ninth power, I can't square root that perfectly, so what I'm going to do is I'm going to break that up into x to the 8th. That's something that I can square root pretty easily. And then the square root, I still have to have that ninth x right there. So power of 8, power of 1. If you were to multiply this back together, it's the same thing as, the square root of x to the ninth power. And then your y seems to be fine. The y to the fourth power, that's a perfect square. I can square root that. So I'm going to go ahead and underline my perfect squares. There's one here, here, and here. Those are my perfect squares. So the square root of 4 is 2. The square root of x to the 8th power is going to be x to the power of 4. And I'll go over that one more time because, oops, well, I can write that here. X to the 8th power is the same thing as x to the 4th power raised to the 2nd power. So I'm kind of manipulating it. I didn't show my work, but that's basically what's taking place. And so what happens here is this gets nullified by the radical sign, and I'm left with x to the 4th power. So kind of similar with we saw y to the 4th over here, so that's just going to become y squared. And then now we want to take what's left behind, and we can go ahead and consolidate them. Just go ahead and multiply that together as a single radical. So that's going to be the square root of 5x. And that's what we're looking at for this one. Okay. All right, so the next one's going to be pretty similar to what we just saw here. It's going to be the same approach. So let's see, looking at this right here, we're going to have to break 75 up. So I got to think, what divides into this that's a perfect square? Let's see, not 5 and 15. 5 and 15, those multiply to give me 75, but I can't square root either one. I think it's going to be, let's see, 25 and 3. Okay, they multiply to give me 75, and then I can actually go ahead. 25 is a perfect square. So kind of like the last one, I have x to the 13th. That's not a perfect square, but what I can do is I can break it up into x to the 12th times the square root of x. So I just kind of siphoned one of those off. I'll do the same thing with the y's. So I'll write this as y to the 6th, and then times the square root of y. So I just kind of broke one off. Once again, I'll go ahead and underline my perfect squares. So there's my perfect squares. So the square root of 25 is 5. Square root of x to the 12th will become x to the power of 6. Square root of y to the power of 6 is going to become y to the power of 3. And then let's see, what's left behind is the square root of 3, square root of x, square root of y. So I'm going to multiply those all back together and put them under the same radical. So let's see, 3x, y. And there you go. All right, so now we're going to move into some cubes. And I'm going to make the first one pretty easy. And I'm going to I'll go ahead and kind of show you all my work on this. So I'm going to manipulate each one of these right here. So 64 can be written as 4 to the 3rd power. X to the 12th can be written as x to the 4th power raised to the 3rd power. And then y to the 9th can be written as y to the 3rd to the 3rd. And so then if I'm cube rooting all this, okay, So you cube root each one individually, okay? You cube root each one, and what happens is they all have the exponent of 3 that basically gets nullified by the cube root. So your answer is 4x to the 4th, y to the 3rd. There you go. So that one was kind of easy because they were all parts of it were perfect cubes. Our next one, all the parts are not going to be perfect cubes. And so we're going to have to make some adjustments like we did on problems 2 and 3. Okay, so our perfect cubes are like, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64. We just saw that one just a second ago. 5 to the 3rd would be 125. I don't think we're going to go above that in these examples or on the exam. I don't intend on going higher than that. So you look at 40 and you kind of think, well, okay, 8 divides into 40. So we're going to go ahead and break that up into the cube root of 8 times the cube root of 5. And then you look at your x to the 3rd, and I'm sorry, to the 7th power. Basically, you need to have that as a multiple of 3, whatever the index is. You need that as a multiple of 3. So what we're going to do is we're going to break that up into the cube root of x to the power of 6 times the cube root of x. So that 7, I broke it up into 6 and 1. The cube root of y to the 9th power, that's already a multiple of 3, so I can go ahead and just leave it like that. So cube root of y to the power of 9, that shouldn't really give us any problems. So once again, I'm going to go through here and underline the perfect cubes in this case. So those are my perfect cubes that I'm going to evaluate. And so the cube root of 8 is 2. And then the cube root of x to the power of 6, that's actually going to become x squared. Ooh. Sorry, this is freezing on me. Let's see if I can get this to work for me. There we go. So this can become x squared, and then the cube root of y to the 9th power is going to become y to the 3rd. And then let's see, this is what's going to be left behind right here. So we're going to be left behind with a cube root of 5x. And there you go. And so going back here, see, like x to the 6th, that could be written as x squared raised to the 3rd power. And so the power of 3 is canceling out, and so you're left with x squared. And y to the 9th can be written as y to the 3rd to the 3rd. And that's kind of what's taking place there. Okay, so I got one more of these here, and so you can see we've got a negative inside here, and so there is a property here. If you're taking the if this is odd, which it is, it's a 3. If you have an odd root, you can just go ahead and pull that negative on the outside, and we can just kind of deal with the problem at hand, and then just realize your final answer is going to have a negative, and other than that, you should be fine. Now, if that was an even root, our answer would be non-real, but we're not going to have to deal with that here. Okay, so let's see. So I got to break 108 up somehow. So if I look at my perfect cubes, going back to look at these, let's see. I think 27 is going to be the key here. We're going to break that up into a 27. So we're going to have the negative still. Then the cube root of 27 times the cube root of 4. And then we got to break that x to the 4th power. We need to have it needs to be a multiple of 3 if you're going to be able to cube root it. So we're going to break that up into the cube root of x cubed times the cube root of x. And then you have the cube root of y squared, which unfortunately there's not really much you can do about that. There's no way to break it up and have a multiple of 3 to where you can cube root it. So really, from the beginning, the y squared is going to be stuck there. But we do have some perfect cubes now. So we have a perfect cube here and here. I think those are our only ones. So I'm going to go ahead and take the negative with this one right here. So this is going to become negative 3, and then I get an x from right here. Okay. And then we're going to take all these right here that are not perfect cubes and put them under one radical sign to basically simplify it. So Instead of having to write it 3 times, we'll just go ahead and put the 4, the x, and the y squared all together underneath the radical. So there you go. All right, so that's page 1.